So this exercise is related to simple harmonic motion. And we'll do the question from this simple harmonic motion today. In the first question, the photograph shows a being. So the photograph shows a bee in a flight. As you can see, the movement of a bee wings can be modeled as a simple harmonic motion. State what is meant by a simple harmonic motion. So what is a simple harmonic motion? The simple harmonic motion, the motion in which the acceleration and displacement are directly proportional to each other, and the, like they're opposite in direction. They're always opposite in direction, the acceleration and the displacement. So whenever a question is there about the simple harmonic motion, the 2 points which you will mention that acceleration is proportional to displacement. And the second one, acceleration is opposite to direction displacement. Or you can also mention that acceleration is always directed towards the center. That's also a term. So either you can mention acceleration proportional to displacement, and the second point you can mention acceleration and displacement are opposite direction, or you can mention it is always acting towards the equilibrium position or the mean position. Same way, you can also define the simple harmonic motion in terms of force, that force proportional to displacement and force opposite to displacement, or it is always directed towards the mean position. The next one, bee wings are oscillating with a frequency of 200. A frequency is oscillating at a frequency of 240 hertz. The wingtips have a maximum speed of 2.25 meter per second. Show that the amplitude of a motion is about 1.5 millimeter. So we have to show the amplitude of the motion is 1.5 millimeter. So the formulas which we'll use, because we have the formula omega is equals to 2 pi f, that is the formula which relate the frequency with angular speed, and then v is equals to r omega, where, or v is equals to a omega, you can also say, where v is the speed, a is the amplitude, and omega is the angular velocity. So first we'll work out the angular velocity. So omega is equals to 2 into pi is 3.14. The frequency is 240. So when we multiply, it will be 1508 radian per second. And then we have the speed was given 2.25. Amplitude we don't know, and the angular speed we work out 1508 radian per second. So we'll divide 2.25 divided by 1508. That will be the amplitude. So when we divide them, amplitude will come out as 1.49 into 10 to the power minus 3 meter, which is about 1.49 millimeter. And we have to show it's about 1.5. So the two formulas, important formula, one is relating the angular frequency with frequency, another one relating the speed with angular velocity. Is it clear, this part? The next one, we have to calculate the acceleration. So acceleration is omega minus a is equals to minus omega square x. So for simple harmonic motion, mainly you have to memorize the formula, learn the formula. A equals minus, negative sign shows that acceleration and displacement are in opposite direction or directed towards the mean position expression. So if we need expression, if for calculation point of view, we don't need this negative sign. So it will be omega, which we already worked out, 1508 square, and multiplied by the displacement. What is x here? X is refers to the amplitude. So that is 1.49 exponent minus 3 because it should be in meter. So when we multiply, this will be 3,388 meter per second square. That's the acceleration. The next part, see, where the wings join the body of a bee, there is a region of elastic material. The vibrating wing muscles set the elastic material to resonate. What is meant by elastic material and what is elastic material means? Material can return back to its same original length, shape, or size once we remove the force or once the deformation force is removed. So, elastic material means that object can return same original length, shape, or size when the force is removed. And what is meant by the resonance, you have to memorize these definitions. Resonance means when object force the other object to vibrate by applying a frequency equal to natural frequency. So it's an oscillating system which is driven by the its natural frequency, and maximum energy will transfer and the object will vibrate with the maximum amplitude. It's of 3 marks. So what are the points when object is forced to vibrate or when system is forced to vibrate by applying natural frequency? That is 1 mark. What is a second mark for when we are applying a natural frequency? That is the 1 mark. What is the second mark? The maximum energy will transfer. And what will happen? The amplitude of the vibration will be maximum. So these are the points related to the resonance. So whenever a question is there, define the term resonance, you will always include these terms. The bee wing oscillate at a frequency of 240, but the muscles only oscillate at a frequency of 60. So that's how impulse applied at 60 hertz can maintain oscillation of 240 hertz. So muscles are only vibrating at a frequency of 60, but the wings are vibrating at 240. So as a result, how even though their frequencies are different, but how they are vibrating with the same, like how it is causing a high vibration. So example, if these are the wings and here is a muscle attached. So muscle is vibrating only at a frequency of 60, but the wing is vibrating at a frequency of 240. So first thing what it shows, the vibration of the wing is multiple of the vibration of muscle, like 60 times 4 is equals to 240. So every time when the muscle is applying a force and it is every time when the muscle is applying the force, it causes a maximum energy to transfer so that it can vibrate quickly. And the frequency of the wing is multiple of the muscle. So it shows that so the frequency of the wing is actually the multiple of the muscle. That's one thing. And then the muscles apply the force every time, same point. At the same point, as a result, what will happen? The maximum energy transfer. And as a result, when the maximum energy transfer, the frequency of the vibration of the wing will be much higher as compared to frequency of the vibration of the muscle. So the idea is that, like example, if there is a swing and it is vibrating to and fro, every time when you apply a force from here, you will increase the vibration of a swing. So when it return back, you push. Then it return back, you push. So this is what is happening here. The wing, when it return back to its original position, the muscle push it again. So as a result, muscle is applying every time more force. As a result, maximum energy is transferred. So wing will vibrate with a higher frequency than compared to that of muscle.